Hello and welcome to lesson 5.1, rates of change using tables. So today what we're going to do is we're going to take a look at how to actually calculate rates of change, specifically average rate of change and instantaneous rate of change using table values. You are going to need to use a calculator to do so. So first of all, what is an average rate of change? Another term for average rate of change, you can also call it slope. This is actually finding out the slope of the function between two different points, specifically given the x values on that interval domain a to b. So let's select point A right here, and let's select point B, let's say it's right here. So what you're actually doing is you're looking for the slope of this line. So you're looking for average rate of change. Oh, to calculate that slope, you can use what you saw in grade 9, y2 minus y1 over x2 minus x1. Or, if we're using function notation, if this is the function f of x, using function notation, you can rewrite it as f at b minus f at a all over b minus a. Okay, so let's move on. So we're going to determine the average rate of change for this function 3x squared plus 5x over these intervals. So to calculate this, you're just looking for, in the first case, f at 3 minus f at 2 all over 3 minus 2. So f at 3 turns out to be the value of 42. F at 2 turns out to be 22. This is over 1. This is a rate of change of 20. Next one, f at 1 minus f at 0 all over 1 minus 0. This turns out to be 8. This one turns out to be 0 over 1. So that rate of change is 8. Let's calculate the last one. So f at 4 minus f at 1 all over 4 minus 1. Denominator turns out to be 3. That's easy. F at 4 turns out to be 68. F at 1 turns out to be 8. Oops, stray mark right there. Let me fix that. And this turns out to be 20 as well. Now you'll notice the average rate of change for the first domain and the last domain turns out to be the same. This doesn't always happen, but due to the fact that 3x squared plus 5x is a quadratic, the first one and the last one, due to the fact that they're centered on the same value of x, means that they'll have the same rate of change. But again, it doesn't always happen this way. Okay, so coming to instantaneous rate of change. An instantaneous rate of change is actually finding the rate of change at a specific point on the function. And it's usually defined by the variable a. Now, in order to calculate this, what we're going to have to do is we're looking for a line that basically just bounces off the function at that specific spot. We call this line a tangent. Now, unfortunately, we're not going to be able to find this tangent, so what we can do is we can take a point that's really close to that other point and find an approximate tangent line. And we call this extra point that's really close a plus h, where h is just the distance from a originally. So if you want to find your instantaneous rate of change, you're using f at a plus h minus f at a all over a plus h minus a. Or if you wish, f at a plus h minus f at a all over h, where this value of h cannot equal 0. So if h did equal 0, you'd get something that doesn't work out. And again, this is only an approximation. So this turns out to be an estimate. Now you can only use this calculation if you actually have the function. Again, if this was your function f of x. If not, you draw it using your tangent line and then measure the slope of the tangent line. So this comes back to a specific detail right here, that the instantaneous rate of change can only be estimated based on the smallest possible interval given. So you can choose smaller and smaller intervals, but you don't have to always choose the same interval. So for instance, you could choose the interval from a to a plus 0.1. Or you can choose the interval from a to a plus 0.01. Or you can choose the interval from a to a plus 0.001. And you don't necessarily have to start at a and move to another one. You can always start at before a value. So you can also choose intervals like a minus 0.001 going to a, or centered on a. So you can also choose something like a minus 0.001 all the way to a plus 0.001. So you don't have to necessarily use what are called preceding intervals, which this one is. You can use following intervals, or you can use a centered interval. And again, the accuracy depends on your sketch or your data that's given. Okay, so let's try to find this. Let's estimate the instantaneous rate of change for this function, and this time we're going to use a table. So I'm going to set up a table here to help me out. I'm going to start at choosing some intervals, and with that interval I'm going to calculate my change in x. Oops. With that, I'm going to calculate the change in y values, and then I'm going to calculate my average rate. Okay, so let's say I choose my first interval to go from the value of 1 to, let's go to 1.01, really, really close by. So the distance in that interval is 0.01. So now I'm going to calculate f at 1.01 minus f at 1 and see what I get. So that turns out to be 7.0601 minus 7. Be careful to make sure you're counting all the decimals here. If you round anything, your answer will be slightly off, or majorly off even. Okay, so with that information there, what we do is we now take that 0.0601 and I divide by 0.01 and I get a value of 6.01. Okay, let's try that again. Let's get a little closer this time. So I'm going to get even closer by another 1/10. So change in x is 0.001. So I'm just using my calculator to work this out. Now this average rate of change turns out to be 0.006001 divided by 0.001. Now, if you are doing this properly, and if there is actually a instantaneous rate of change that exists, then these values that you have here are going to get closer and closer to a specific number. Now, that means you can estimate your instantaneous rate of change is approximately the value of 6 is my best guess. And again, it's all based on what you find. Okay, so last item. Let's estimate the instantaneous rates of change here in this expression. So what you do is we're going to find the instantaneous rate of change at -3 and 4. So locate the value of x equal to -3 and x equal to 4. And then you try to draw tangent lines. Because I'm using an iPad here, I'm doing this by hand, so I hope these tangent lines are okay. A tangent line basically just touches and glances off the function. Once you have that, all you do is you measure the slope. So for this tangent line right here, looks like my slope would be 1 unit over 2. So rate is equal to 1 over 2. And for this other one, the rate, I would say, take 2 points. That looks like it's 1.5 over 1 unit, so 1.5. Whereas this one is 0.5. And that's how you estimate the rates. And again, it's an approximation. It's not 100% accurate, and each person's going to get something slightly different. And this concludes this lesson 5.1.